Have you ever wondered what makes specialty pigments like metallics or interference colors so special? Or asked yourself how you might include these distinctive colors into your painting regime? My name is Jeff Olson, and I am the Art Education Director for Royal Talents North America. In this video, we will explore the unique composition and working properties of the Rembrandt Special Effects watercolors, and hopefully provide the catalyst for you to explore the potential of these amazing paints in your own work. Rembrandt Special Effects watercolors come in 4 distinct categories. The first are the metallics, which include silver, light gold, copper, and graphite. Then we have the interference colors, which come in white, blue, violet, and green. Both the metallic and the interference colors are made from sustainably sourced artist quality mica pigments. The next 2 groups of color, the spark and chameleon, are made from oxidized glass pigments. The colors include spark green, blue, violet, and pink. And in the chameleon colors, we have a range that shifts with the changing light source. The first is the brilliant gold, red, violet, then a rich red, violet, blue, followed by a deep violet, blue, green, and the last is a stunning blue, green, gold. All of the Rembrandt Special Effect colors have our highest light-fast rating and are semi-opaque, giving them both longevity and the ability to create more opaque layers of color compared to traditional watercolors. Traditional pigments are what we refer to as being one-dimensional. The light waves hit the pigment itself, and the dominant light wave that's reflected back is what we perceive as the color, in this case blue. Two-dimensional colors, like metallic colors, the light waves come down, hit the surface, and they are all reflected back, just like what happens when light hits a mirror. The color we perceive, being gold or silver, often comes down to the mineral content of the pigment mica itself. Finally, we have three-dimensional pigments. Here, the base mica pigment is oxidized with multiple layers. The light waves hit it, and depending on the strength of the light wave, it penetrates the different levels of oxidation at different layers, coming back and interfering with each other, which is why these pigments are often referred to as interference pigments. Depending on the direction of the light source or our position to the surface, the colors can transform from the dominant to the subordinate light wave, giving us an appearance very similar to a pearl. To begin our exploration, we'll squeeze out a small amount of each color into our palette. We'll be using one each of the special effects colors, a metallic, an interference, a spark, and a chameleon. You can choose whichever of these colors you have on hand. Next, we'll lay out our paper, overlapping the white sheet with the black, leaving about a 2 to 3 inch strip of white horizontally at the top. Now it's time to dip into our color. Using a small round brush, and beginning with the metallic, we'll create a color swatch that overlaps both the white and the black sheet that is approximately 2 to 3 inches in length, then repeat that with each color. As you're applying the color, note the difference of the color's appearance on both the white and black paper, and how the difference in the absorption of light into each affects our perception of the color. Once you have the swatches complete, pick up the 2 sheets of paper, moving them back and forth to the light, and note the changing effects as the light source is altered. For the next part of the exercise, we'll add our primary colors to the palette. They can be in any order. Apply these to the black sheet of paper only, laying them out on the left side in a neat column of swatches, approximately the same size as prior. Now for the fun part. Let's mix some colors. We'll begin with the metallic and mix it with each of the primaries in order as they are laid out on the palette. Then create a swatch underneath the metallic swatch and next to its related primary, creating a grid. When you have the first column complete, lift and turn the paper and observe how each mixture creates a unique effect. Now repeat this step with each of the remaining special effects colors, stopping each time and observing the effects created in the mixtures. The special effect colors can also be used to create stunning glazes. Using a clean brush and beginning with the interference color, lay the color over the top primary, in this example the yellow, covering half of the swatch. Repeat this with the spark and chameleon colors over the remaining 2 primary swatches. As these glazes dry, pick up the paper and note the shifting translucency from opaque to transparent, as well as the unique hues that are created. As the swatches dry, you'll see how these dynamic colors retain their luster, in some cases increasing the effect. While being re-wettable like traditional watercolors, you won't see any unwanted flaking or glitter coming off the surface. I hope you've enjoyed this tutorial on the Rembrandt Special Effect watercolors and that you're already imagining the possibilities of incorporating them into your own work.